In this video, I would like to show you a few more examples with loops and using list comprehension statement syntax. So our next sample code is video 8.4 comprehension. And here, this other interesting feature that we need to mention here is that in Python, we can have nested lists, or otherwise lists of lists. So nested lists are lists made of lists and often referred to as a matrix if it's like, 2 by 2 or 4 by 4, kind of like square or rectangular matrix type of thing. So here's an example of a list, right? It starts with the all familiar square bracket notation. And then, so after assignment, we have the opening square bracket, and Python interpreter understands it as lottery draws is a list of lists right here on this list. And again, I use more of a, like, instead of writing everything on the same line, the square brackets allow us to split it to multiple lines and use indentation to our liking and specify what the elements are. And in my case, these are like lottery draws of individual, like, lottery balls for 3 different days. Okay, so we have a little information here about 3 lottery draws. So these are just random numbers. Okay, so of course, if we try to analyze what this is, at first, I always was curious, is this going to be shown as a list of lists, or what is it going to be showing as? So let's basically run this sample code. So this is our video 8.4 comprehension. Okay, let me just select this and copy and paste it right here in this window. I run it. So you can see this very first output statement says what is the type of lottery draws. So the understanding of it is it's just a list. So it's really generic dynamic type, which is very, very flexible. And even a list of lists can be done, but all the knowledge that you get about it is just a list. Okay, so it's not anything specific to nested lists. And then another interesting demo about the indices is that if you think about a list of lists, as I have here, a list of lottery draws, and each lottery draw is a list of integers, right? So if you use square bracket notation next to the lottery draw, it will return naturally. So this part right here that I'm using, it will return the initial element of this list, which is a list of integers. And therefore, so this part right here returns this list of integers. And if you apply the second index, it's like row and column, okay? Matrix access, it will give us access to initial value in this list, which is 10, right? So this is why we get 10. Then I try number, like index 1, which refers to the next element here. And if I switch over to a row number 2, remember these rows are also numbered 0, 1, 2. So this is the last row. And I go to index number 4, 0, 1, 2, 3, 4. It returns number 47 from this list. Just a demonstration of nested lists or matrix type of list, and using multiple indices with an idea of a row and column. Right, so there could be more nesting here. We can use like a cube idea or even more dimensional type of list if you'd like to do it in your coding. So next example is just basically, this is now we are dealing with integers as our individual elements. And now I would like to say, what would be the code to find duplicate numbers in 2 consecutive draws, like one draw, another draw. are there any duplicates? Okay, so if you think about it, like I noticed that this number 29, right, is a duplicate, so it rolled again. It was drawn again, and then the next day after this one. So in order to be able to, so my first idea about it was, okay, if we have these repetitions, then we need to be able to sort of compare the current draw with the previous draw. So this is why when I put this together, this is not using comprehension. However, I thought this would be a good example of using for loops in our discussion, right? So so I came up with an idea of a previous draw, and I use it as an empty list to begin with. Okay, so then I say for a draw, right? So the draw is, in this logic, is the whole row of numbers, which is list in itself. So I say for one individual draw inside the lottery draws, right? So inside this long list here, if the length of previous draw, originally the length is 0, but I say if the length is not 0, remember that length gives you the length of the list, and anything that's non-zero in Python is true, considered by as long as the if statement is concerned. So I say if it has some length, so it's not empty like at the beginning, then I run through every previous ball in the previous draw, and I say then also for the ball in the current draw, this is the current draw, and this is the previous ball, if the values are the same, then print. Okay, so this is where it comes, and I say for this previous draw, which is this, right? So this is the previous draw in this example right here, and this is the current draw, right? So these correspond to this. This is the previous, this is the current as a result of my processing here. And I say, as long as the values are the same, just simply print both of these and say repeat is this ball, and I use just space to put everything on one line, right? And so notice that also I find that there is another repeat, which is 3, right? Clearly 3 and 3 are the same. So again, this time it's this draw and it's this draw, like this one here and this one here, and we again have a repeat. Okay, and at the end of this attempt, I just update what the previous draw is. It's just the current, but in the next iteration, it will be used as a previous. But originally, it's empty, and this is why we have this statement. We say, if length of previous draw is not 0, then it's safe to assume that we already collected previous, and now we have the current, and we can run all these nested loops to make our comparison and eventually get to the balls that repeated themselves in the next draw. So this is this example 842. Next thing, I thought that, okay, how about we try some things to use comprehension statement syntax with integers, this is this specific example here, right? I could just use it on a single line, but I decided to split it into multiple lines here for this demo, and this is typically my coding style anyways, to use multiple lines. So I say if list comprehension so this list comprehension statement is very convenient to flatten a matrix, right? So if this was like matrix that was defined without internal lists, just like a whole list of all of the integer values, so it's possible to use this statement to flatten the matrix. So I say flatten draws, right? So the draws that just like appear to be a simple one-dimensional list of integers, I say this is my expression, it's the ball, it is derived from the following combination of 4 loops, right? They're also nested loops, and I say for each draw in our lottery draws, and for each ball in every draw. And this is where the values coming from, right? So we say, okay, there's another ball, there's another ball, there's another ball, and these are two nested for statements. And so we're gonna get a list. And when I do this, flattened draws appear just one simple list, and you can see there's like 5 and another 5 and another 5 numbers, but now it's one-dimensional. It's no longer a matrix, okay? And if we use this flattened version of the original list, which was like this, multidimensional or matrix type, if we try to print, like if we try to use two-dimensional syntax, thinking really the content hasn't changed, it's just became one-dimensional. Now the list types will not agree. So if I just rerun it just to show you, right? So it's going to give us this type error. Integer object is not subscriptable because now the first index simply returns an integer from this list. And of course, the integer itself is not a list. This is why it cannot be further subscripted. So we get this type error, blah, blah, blah. So it's understandable. So that is no longer available. So that works only with matrices. Next example, 844. Let's just save everything and rerun it. So we have, again, a clear picture of this sample. So this section here is section 844 that I'm looking at right now, right? So a sorted function takes the list and returns a sorted list. It's really cool. You can just sort it. Like if you say, I want to sort my list of strings or integers. We have quite a bit of examples in our online textbook, as well as all of these tutorials. I give you links to look at, but the sorted function is just something that deserves to have another look. So it's very simple, and of course with our sample here, you can see that now all these numbers were sorted in ascending order, right? So there, and it also demonstrates very nicely that lists can contain duplicate values. That's not an issue. It's all populated sequentially, manipulated sequentially, not a problem. We can store, one list can contain like 10 values of the same value, like 10 elements of the same value. Here's another example of a comprehension statement, which list comprehension statement, of course, always is included inside the square brackets. But instead of using the result, I'm using the expression to do something, to manipulate an empty list. And I say unique balls. How can I basically drop these duplicates, right? 3 and 3 and 29, 29, and 28, 28 are also duplicates, right? So I just want to get rid of them if I don't want any duplicates. Just another kind of exercise using this comprehension statement. So I say, oftentimes, by the way, I'll give you a little tip, is that before you get to this, this is what's confusing about this comprehension statement, is that the expression, which is like number 1 in the syntax, is easier to understand after you look at the loops, right? Because in the loops, these pieces are defined, and here they are simply used. So therefore, like, don't look at this, just look at the for loops or if statements, everything that's present in the processing part, and then go back to the expression which does something or returns individual elements. So anyway, so we say for each ball in flattened draws, right? So this flattened draws is just like simple a simple list of integers. I say if the ball is not already in unique balls, then use it. And instead of using it as a brand new list element, I just say unique balls append ball, right? So it's just really kind of like abusing the power of this comprehension statement, because its initial design is to generate new list, and it does generate new list. But instead of using that result, like outside of these square brackets, I'm actually populating this initially empty list with these new values, and the result is happening to be a unique list of unique values. There are no duplicates. Okay, so that's the idea. All right. And similar to our initial attempt here to find duplicate numbers, although it's not the same, but here I just say, if we want to identify duplicates in a list, right? So I created this new list, but my flattened or sorted values or flattened draws, they haven't changed. They're still in memory, right? So going back to this last section in this sample, also using comprehension, list comprehension in Python, you say, if we want to identify duplicates in a list, it's possible to use a collections counter function. And this is this counter function from Python library. And because it's from the library, we need to import collections. Typically, these import statements go to the very top of the code, but they don't have to be, right? As long as this import appears to be before the use of the element of Python library, which you need to be able to import, it all works. So it all works in the same code. All right, so back to this counter function from Python library, right, creates a new container that stores elements as dictionary keys and their counts, right, the key and the value pair so the counts of elements stored in dictionary values. So it's a really kind of like interesting feature that we will discuss in our next videos. We're going to talk about dictionary values, right? So we will cover dictionaries in our next set of lessons. But today I just thought, since we're already looking at this, idea of integers and duplicate values, I thought this would be really cool to try here. So a pair of variables ball and count is used here as in this for loop, because in this comprehension syntax, it corresponds to dictionary key and dictionary value in the container return from collections counter. And counter, by the way, takes I use flattened rows here as an input. So it says, okay, give me a list, and I will give you a list of these numbers and their counts, how many times they're found, and they're all unique. Okay, and then the items returns basically a list, and I say that then if the count is greater than 1, I would like to use this ball as the result that I eventually collect into the list of duplicate balls, because all of these balls have counts greater than 1. Okay, so yeah, so again, lots of talk about all of these things, but the code is surprisingly very, very dense, like kind of terse. Is not a very long piece of code, right? But I do get my duplicates, right? So 28, 29, and 3 appear to be in multiple draws, right? So this 28, 29 here, and 3 appear to be like on this in this initial list more than once. Okay, so they have counts greater than 1, and this is why we display them right here. So I call them duplicate balls. So this is our series of demonstrations. So again, reminder, please use all sorts of samples, and definitely I strongly recommend that, first of all, you read the chapter of the book and then review these tutorials. You may find that you need some extra time. This is why there is no programming project this week, but please work seriously on all of these examples, because list features are core features of Python, and all of them are used very extensively in all non-trivial Python programs.